Kia ora. So we have a problem. An evil vampire has stolen some expensive and rare jewellery from us and hidden it in his haunted castle. He's put 2 layers of defences up in order to get to the treasure room, and each one is guarded by a separate network which has its own security system helping protect those physical defences. He's got the outer walls, which have their own security system, and an inner security system. But we're getting a bit ahead of ourselves. Firstly, who am I? Kia ora, my name is Jess. Professionally, I've got 13 years worth of experience in pen testing. Last year, I co-founded Pakiki Security with a couple of my former colleagues, and I've spoken at many conferences over the years. I just look a little bit different this year. In my spare time, I quite enjoy gaming. Currently going through another Factorio bend, which takes up a lot of time, and quite enjoy exploring, so going for drives around Wellington and bushwalks, etc. So what are we up against? We've done a bit of reconnaissance and found that the vampire is not very good with security. Each outer layer of each network is sitting on a public wireless network. He's also not very original. He's using the same architecture for each of the 2 networks. It's a Linux machine talking to a Windows machine. But he knows that security is very important, so for each network, he's running a separate EDR. In practice, when setting up this exercise, I used 2 metasploitable virtual machines, which are intentionally vulnerable virtual machines designed so that attackers can practice their tools and techniques against target systems. They've got a lot of vulnerabilities intentionally. So what is an EDR, you might ask? According to Wikipedia, EDR is a cybersecurity technology that continuously monitors endpoints for evidence of threats and performs automatic actions to mitigate them. Basically they continuously log the behaviours on endpoints. They collate the events and will alert administrators if something's going wrong. They'll block particularly suspicious behaviour. So for example, if a process starts walking through each of the files on the file system, reading them, and then writing back something different, probably going to go, that looks a bit like ransomware. I'm going to stop that. And if you read the vendors' websites, there are advanced AI platforms that'll stop all of the attacks right where they sit. So what's the plan? We're going to send a ghost cat into the network, and we're going to need to craft her potions in order to move throughout these networks. In practice, we've used the MITRE ATT&CK framework to kind of base our attacks on, and similar to a real-world attacker trying to get access to a corporate network, we need to create potions to do initial reconnaissance, gain access, escalate our privileges, maintain persistence, move laterally, and exfiltrate the data, all while bypassing the EDR. Now, given EDRs tend to look for suspicious behaviour, I was tending to find that living off the land was the easiest way to do this. But it's quite fun to also work through different types of attacks. So let's start with our first potion. So the first thing we need to do is reconnaissance. So we fired up our trusty Nmap tool, which is a basic standard port scanner. Using the -A flag, we were able to fingerprint the services that we're running. So from our attacker's machine to the target Linux server, standard Nmap. It gave us a list of the services that we're running, and needless to say, that didn't trip the EDR. It's not necessarily looking for network-based suspicious behaviour. They are more looking for process and on-host behaviour. One of the services it was running that looked particularly interesting was an old version of IRC, which is the OG Slack. And there was a vulnerable IRC daemon running that had non-vulnerabilities. So the next step I did was bust out our trusty Metasploit. For those who don't know, Metasploit is basically the Swiss Army knife for exploitation of vulnerable network services. It contains a massive database of exploits, and you can then select which payload you want to execute once it's carried out an exploit. So The different types of payloads, for example, that we can send include things like a reverse shell, where once the process has been compromised, it will then call back to the attacker's machine, so it's coming outbound from the network and calling back to us. We can set it to do things like a bind shell, where it will basically give us a console that we can connect into, and it'll open up a port on the target machine. And there's other types of shells as well, like a I can't recall the word, an interpreter shell, which is, rather than say like a Linux console or a Windows command prompt, it's a specific shell that's built into Metasploit that's designed for exploitation and further things like privilege escalation and enumeration and tunneling traffic, etc. Now, what was quite interesting here was that most of the target exploits and payloads for the initial EDR I tested also did not trip the EDR. There were a couple that did, but the vast majority did not. Next step, we've now got ourselves a shell just by using Metasploit. So, next step is to escalate our privileges. So using benign Linux commands, was able to start to explore what was going on in the system and try to look for a path for root access or pseudo access. So first thing I did was just use the ps command to enumerate all the processes that were running on the system. It had a lot of running processes that looked very interesting, and based on that initial scanning that I carried out using Nmap, I could have predicted that there'd be quite a few processes running on the system. So could tell that there's going to be lots of opportunities for privilege escalation in this particular case, which was not surprising given it's an intentionally vulnerable system. After that, what I thought I might do is again, continue looking for the lay of the land. I opened up the etc group file to get a list of the user groups on the system. One of the groups that caught my eye was the sudo group, which for those who are not fluent in Linux is basically the system administrators group. And that had a few users, Leia, Luke, and Han. So if we can get one of their passwords through another vulnerability, if those passwords happen to be lying around on the system somewhere, then we can get access to the system as an administrator. From there, I basically searched through common places on the file system where passwords might be stored in plain text. So I searched through /var, which is the location which things like databases and other system services tend to store their data. It's also where web source code for web servers tends to live as well. And nothing was immediately found there. So I thought maybe I'll take a look at what web applications are running on there. One of those happened to be what's called the payroll app, and given that that was just a single PHP file, I thought that's probably going to have quite easy code to start to look through. So I opened up that code, and right at the top was a username and password to access the MySQL database. And again, this is all running on that shell that we'd got through Metasploit initially. From there, I was able to use the MySQL command to basically enumerate the database, export the users table, and lo and behold, that application was not encrypting or technically hashing passwords in plain text. Oh, sorry, it was not hashing the passwords and was instead storing them in plain text. So I was able to get Leia's password to the payroll app. Now, of course, scratching our heads, who would reuse passwords between, say, a payroll app and, say, remote system access? Hands up who reuses passwords? So, lo and behold, I was indeed able to just then SSH directly into the system from my host. And that gives us what we call an interactive shell, so we can, it gives us a bit more flexibility as part of the exploitation. And because we know that Leia's in the sudo group, we can then use just her standard password to use command sudo su, which will give us a root shell on a Linux machine. So we now have full complete root access to this Linux machine without tripping EDR. Next step was to persist access. Now, depending on your goals, this technique is noisy, it may be detected, it's a bit rough, but if you're a pen tester, for example, then yeah, very much will depend on what you're trying to do, and it'll depend on your target as to how noisy you want to be. But this works for our case, and what I did here was I added my public key into the layer's authorized keys file, which on Linux basically means that when I try to log into the system remotely using SSH, my system will have a private key on it. That server has that public key, and they'll do a handshake, and then I can log in without my password going forward. And then, a bit cheeky, again, in case Leia changes her password in the future, what I did was modified the sudoers config so that going forward, Leia does not need to enter her password to perform privileged actions. Okay. She might pick up on this and alert somebody, but in this particular exercise or instance, that is acceptable. So what do we do next? Well, we want to try and target that Windows server and understand what that's running and try to target the services on that. So sort of curious to see how far I could push it. I kind of had this assumption that at this point I was basically operating as a legitimate user, and EDR is probably not going to trip. So I installed Nmap on the target compromised server, and that worked. That was fine. So I used that to then scan the target Windows server, again using similar command to when I performed the reconnaissance on the initial system, so using the -a flag to basically do full fingerprinting. One thing I did try at this point was using what's called an SSH SOCKS proxy, which is effectively using that SSH connection as a proxy or to tunnel the traffic through. And the EDR did trip and get quite angry at that, which I found quite fascinating. But I suspect that, again, if we're trying to live off the land and use native tools for what they're designed for, if I had, for example, installed a VPN, I suspect that would have worked fine, even if it was running in like user space or something. So one of the services that was running on the Windows machine was a web server that had WebDAV enabled. WebDAV is an older file sharing protocol, and it was configured like old school web hosting. So we could upload files to that share, and then the web server would host those files and serve them up for us. So I did what sort of came to mind, which was used MS Venom, which is another tool as part of the Metasploit suite, to generate a PHP shell. So this is malicious PHP code, or malicious, that we can upload to the server, this Windows server, and in that particular case it was a reverse shell, so it would call back to our attacker's machine with an interpreter console, which is again that shell that gives us kind of commands designed for post-exploitation and a few other functions. Again, I wanted to see how far we could push it, so I installed Metasploit on the exploited server. And again, the EDR did not trip, which blew my mind. There is no real use to Metasploit other than trying to compromise machines. The Windows machine was very out of date, and it was also vulnerable to Eternal Blue, which is an old school NSA exploit. And again, quite fascinated to see that exploiting Eternal Blue from a compromised machine also did not trip it. It was also running a number of Java services, and interestingly enough, a lot of the Java exploits did trip it. But yeah, basically using this technique, I would then use Metasploit module just out of curiosity to upload this interpreter shell to the target Windows host. There are other native tools that I could have used to do this that are a lot less noisy, but this was fun. And then from there, I was able to compromise the Windows system. I had effectively code execution on that at that point, and I could download or start to explore the data and download the access keys that we need to gain access to the outer walls. Woohoo! We've compromised that entire network and we've got access to the data. So what's next? Let's compromise the inner security system. Well, guess what? That same chain worked for the other EDR. I did need to make a couple of tweaks, like the second EDR that I tested this against needed or had signature-based detection. So I did what we've always done when trying to bypass antivirus in a professional sense. I just slightly tweaked the payload so that it no longer matched the signatures that were built in, just by adding a couple of extra characters. And I did also need to use a bind shell rather than a reverse shell. So in that particular case, it was opening up ports on the target server rather than calling back to us. So, success. We got access to the castle, we got access to the treasure room, and we can get our stolen jewelry back. So, tips and tricks. So, if you're an attacker, some takeaways for you. Try the simple stuff. This is something that I always teach people who are getting into the industry. Don't take anything for granted. Sometimes the really simple, silly stuff just works. Sure, some of the stuff that I was trying was a bit more sophisticated, but yeah, the simple stuff sometimes just works. If you can, when you're trying to exploit a system that has EDR, live off the land. Because again, it's looking for weird and odd behavior for processes, so if you can try to minimize the amount of odd behavior, it doesn't trip, or trip as often. Test what you're about to do in a lab environment. I'd say about half the stuff I tried didn't trip it, and that might be a result of just the specific things I was trying, but yeah. If you are actually trying to be stealthy in an engagement, you basically are going to need a lab environment that's running your target's EDR, and that you can then set up kind of the same misconfigurations that your target has, similar vulnerable services that your target's running, and then you can test to see what payloads and exploits work and which trip it versus which don't. And lastly, go slow. So some of the stuff I did, I got the impression when it was tripping that it was because it was getting a bit angry because it could see that automated tools were doing the stuff. Whereas once I started to do it manually, it was a lot happier. Yeah, and if you're a defender, some takeaways or some tips. Don't ditch the EDR. Like, obviously this makes the job a lot harder. So, as I said, about half of the things that I tried here were stopped by the EDR, so it definitely is harder. But despite the vendor claims, they're not going to stop all attacks. Which kind of leads to the next point of layer your defenses. So, if you recall back, say, during the COVID response, and like in aviation security, they talk about the Swiss cheese model for preventing accidents. Same thing in security. So you can think of each layer of defense that you've got as a layer of Swiss cheese. Each layer of your defense is going to have certain holes that can be worked around or exploited. EDR is just another layer of Swiss cheese, effectively. So if, in this particular environment, things like system hardening, updates, MFA would have stopped these attack chains, and intrusion detection systems, both at a network and host layer, and logging and monitoring would have helped to at least detect these attacks and alert on them. Next, make sure your EDR is configured appropriately, so these tools can or have a number of settings on them, which allows you to adjust how, well, that sort of balance between how assertively they stop attacks. So make sure that it's cranked as far up as possible without impacting your users, and if you need help there's I'm sure some people in the room who can happily consult and help with that. And then also you could consider testing your EDR. So tools like Atomic Red Team, for example, will send a battery of tests against the system and let you know what's been stopped versus what's not. And if you do that sort of thing, then it will allow you to at least know where the gaps are, and then you can start to kind of just think if there's any additional controls that you might want to put in place to plug those gaps. So thanks. If you have any questions, I'll be floating around the conference. You can get hold of me, probably my work email address is best, which is jess@pakiki, or you can find me on LinkedIn. So, kia ora.
I am a super genius.